Sir, good. Is my voice audible, sir?
Yes, ma'am, you are audible, ma'am. Good morning, everyone. Welcome to today's session. Thank you so much, ma'am, for accepting our invitation. Dear participants, today the speaker of today's session, Lakshmi Swarupa ma'am, will take the charge. Thank you, ma'am.
Is my voice audible, sir?
Yes, ma'am, you are audible.
Yeah, I'll be sharing. Okay, good morning to one and all. I'm Dr. M. Lakshmi Swarupa, Professor, AAA Department, CVR College of Engineering. So today we are going to discuss about and descriptive analytics. So before going that, I think throughout your FDP, I think you have seen the basics of maybe of data analytics, what is the data analytics and how the data analytics is useful for various applications, right? So briefly, we'll be seeing how the data analytics is very important. So we have in different applications related to data analytics in an areas of applications like electrical, or if you see automobile, or if you go for a big data analysis, or if you see an example of in hospitals, or for a different type of in groups categories which are have the data in sharing of in public. So the analysis of an data is very, very important on the basis of surveys. So there are again 5 categories of an data analysis. These are the basic, just I'm showing 2 slides of it. So 5 types of an data analytics are there. One is in descriptive, one is in diagnostic, one is in predictive, one is in prescriptive, and cognitive analysis. So 5 types of analysis are there. So we'll be discussing now about a descriptive type of an analysis. And the big data analytics helps us and business people or and today's of huge data resources. We can see example like in organizations, or if you have taken institutions, where the massive data of an application comes into a picture, where the data analytics is also required. So you can also say an big data analysis for that. So simple example, we can see now the growth of an renewable energy sources or an electric vehicles or hybrid electric vehicles have come into a picture of so much that and taking a charging for an electric vehicles is becoming a very big data. So in the future, maybe on 2050, all the vehicles may be converting. I'm taking an example of an automobile. So all the vehicles will be conventional vehicles will be converted to an electric vehicles also, where the data analysis is very important, because the battery charging of an each and status of the battery for in each car used by different people is very important. So that comes under cloud application and also machine sensor data applications also. So the data analysis process for any application, we have to do the 5 steps, which are very important, because getting a data into the required form and doing its analysis is very complex in nature. And it takes two things which are very important. It is to be an efficient data, and also it is also to be an effective in terms of doing the analysis. So the 5 points which are important for a data analysis process, either it may be for any application. The first one is an identification of the data. So we need to identify first what is required for a company, or what is required for an individual, or what is required in a private or a public. Suppose if you take example of an hospital, so they require some blood samples of something, or they may require some measurable parameter of a patient, right? So that is an identification of the data, and that is different, depends upon the type of patient. So the patient problem may be, the health issue may be different according to the different situations, age factor and gender factor. So identification of what is a problem is a first thing what we require. That means what are the quantities which are to be measured. That is the first thing. And next is collecting the data. The collecting the data, we can collect from a different types of an sources. Like we can also collect from a company's client relationship, or you can also go for some softwares which are always collecting the data and storing in an Excel format or an Oracle, or you can go for any database storage system. And we can also take the data from an live that government records, or also go for a social media application interfaces. Now many of the APIs are there. If you take examples of the apps which are there in our mobile, now if you go for a Google store, we have plenty of the apps. Simple example, we can see the weight management of ourselves, knowing the BMI status and what we are eating, how much calories we are consuming per day. It is a very big challenge. So we can also go for a secondary type of an applications or an application programming interfaces like this. So next third thing is cleaning the data, because our data is not that much perfect. It may be having some inconsistencies. So we need to go for a standard format of the data, because we want the data to be in a data structure or a standard format which is required. And we don't want any errors in it. So we need to clean the data. Next is analyze the data as per the different tools are there, and different types of variations are there, where we can go for any type of a graphical format or any type of a descriptive format and analyze the data what is there in the term of an analyzing the data. After analyzing the data, we need to interpret what the data will mean, because the conclusion, this is same like how we write a project or how we start any work. If you do example of a cooking or anything, it's like an identification, collecting the data, cleaning the data, analysis, and interpret the data. So after interpreting, then we need to check whether the received output, whatever the data, is solving our identification of the problem or not. So that's how the data analysis process will come into the picture. So we can say it's a continuous improvement toolkit. Now even some of the students or some of the PhD scholars who are there in this FDP, even they can also work on continuous improvement of a toolkit in terms of a descriptive statistics. Then we'll get it out what actually this continuous improvement map indicates. So if you see this, these are all the many of the topics which we have done in our management courses, we have done in our mathematics. Even also if you see, we have also gone for different types of an subjects which we have already studied. So first one is managing the risk. That is very important because we should know what are the problems are there and what are the solutions are there for the existing ones. Next is selecting and decision making. We can see here break even analysis is one of the method. Cost benefit analysis is one of the method where they are using for the selecting and decision making of the applications, right? So these are the different methods or techniques which are already there. Next is planning and project management. It's very, very important because after planning, we should go for the implementation of it. So that is one of the highlight point of an continuous improvement of an descriptive statistics. Understanding the cause and effect, we should know what is an. I think we have learned about what is correlation and regression also. Nowadays, the regression is a very, very big topic and it is common for all the branches. We can go for a multilinear regression. That's a very big problem because multilinear regression consists of many input variables and many output variables. If you take a simple example of y is equal to mx plus c, that is a simple straight line equation. Y is equal to mx plus c. So y is an output and x is an input. We can take n number of y's into in the matrix form, that becomes a multilinear regression. That's what we are searching for now, data collection in terms of a huge data. Next, implementing the solutions. The implementing the solutions can be in different form, and data collecting, understanding what the performance is, and it's designing and analyzing, and also the group creativity, what you're doing, how you're understanding. Are we separating the data or are we taking in a group? What is the difference between our different membership functions, or if you take any fuzzy logic, or if you take any type of an artificial intelligence techniques, how we are trying to move the data comes into a picture. Next, we'll start with a descriptive statistics. Now, in depth of a little more about the descriptive statistics. So the statistics, we have heard that word, what is the meaning? That we are describing or interpreting any analyzing of a data. The data analyzing is very, very important. Suppose if you take a simple example, in our home, we have n number of pencils or n number of sketch pens or n number of erasers, everything kept in one box. It's a stationary kit. Is it easy to pick up any particular identity? We have to search unless and until you know the shape, unless and until you know its quantity, its color and whatever the things. If you know its properties or characteristics of that particular data or in particular entity, you can easily pick up. Otherwise, it takes a lot of time to do, but those are limited data. So the limited data is very easy to pick up. But if you take a data which is an unlimited or unsymmetrical data, it's very difficult to pick up, is it not? So for that, essential element of instrument is necessary. So for statistics, there is often two categories. One is an descriptive and other is an inferential type of an statistics. So now so many of the researchers are working on descriptive type of an statistics now. So it uses an analytical methods which are used to model and predict first variation. We generally have this issue. You need to understand what the data is, okay, and go for the analysis and then predict what actually the data is and how it is varying with the time present situation. That's very important. So it uses graphical methods to help us to visible for communication. How do we communicate with the data? That's again a big challenge. We know that by using analytical methods, we understand this is a data. Fine. Then how do we communicate with the data? How do you see what actually happening? So if you see in terms of a values, you may just analyze it. But if you see in terms of a graphical representation, then you can even know the perfect communication, how the data is been varying. It's a simple example. We can see the share market, the things. Now, if you see in every YouTube or something, the promotions will be given for a share market, right? You can also do some business related to the biddings or economic biddings on some particular type of a marketly available products also. That is also one type of an thing which is happening in a market analysis now. So this is an example which has been taken. So why we have to go for statistics for a data? Is it necessary or not into a picture? So when we see data, you will get a doubt when we have to go for a data. The data is again of two categories. One is limited. Can all please mute yourself? The data is of two categories. One is an limited and other is an unlimited data. So the data which is in finite data and which is in a small in quantity need not go for that statistics analysis of the thing. But when you see the data of a descriptive type of an analysis, naturally we should know what is the process to be done to acquire the data. And also, we should also know the data, whether it is good, the services are good or not for a particular product, is it not? So to analysis of an data in a process and to see the product, whether it is good or not, so you should do some analysis in terms of a statistics, that is measuring in terms of a quality. So quantitative and qualitative analysis are most important in terms of a statistics. We have already learned about probability and statistics in our many of the applications, because now if you take the weather, we cannot say whether now sun may come or it may not come. So that is a fuzzy type of a question where we cannot give the answer. But the predicting, that's what they have done. Right, so the prediction has been done that 3 days rain may be there or 4 days the rain may be there. So it's an climatic type of an analysis which is being done, and based on that the improvement process is being done and real world analysis also can be done. So if you see what are the different methods which are already there, there are already there many methods and there are different application specific data. If you just give the data, it will calculate and tell you what are the different data sets are there and how to separate it, right? So, but it's very difficult to understand if you want to do an analytic way of analysis. So what all are required? First, if you want to go for any data methods, you should know where the characteristics of a data set is to be known. If as I told you, example for a stationery kit, you have n number of pencils, n number of pens, erasers, sharpeners, etc. But the characteristic of an each particular entity in that stationery kit is not same, is it not? So for that methods are, you should know to how to first identify the characteristics of a data set. So that data in giving input to an method or an app is very, very important. Second step is you need to know the sense of a data. That is what actually the pencil will do, what actually the output of a pencil is, or the output of a pen is, or output of an eraser is. If we generally say eraser, we know that whatever we have written with a pencil can be erased, is it not? So we should know the sense of a data with the characteristics. And the third thing is you should also explore it and making conclusions of the data in order to make a rationalized type of a decision. So you should know the data very clearly, and you cannot say that eraser means it erases everything. Can you say like that general statement or conclusion? We cannot give, because a pencil is different and an pen is different, is it not? So for giving a rationalized type of a decision, we need to go and explore it, what actually it means, what is its input, what is its output, what can it do. Next, it go for an including calculation of things on an average data, or a spread and or a shape of it produces is very, very important. See, if some type of an pencils, maybe many type, if you take an example of Natraj pencils, you may have 10 and some are from only for drawing and some are from only, again they are pencil category, but again they are in a huge number of different categories of pencils again. So it may be so much of spread, range is also large, where you don't know which type of pencil is to be used for which type of application, right? And its shape also, it produces a different meaning. So if you take an example of this, it's a balance weight, where we are telling the weight of a product is very, very important, and also the time taken to process an application, that is very important. Even though you have a balance weight, you need to put the weight and you need to check what is the time taken for making it balance, or what is measuring its particular product weight. So both type of an variables are very important for understanding the balance weight of the particular application. That's a small example. Now everything, if you can see in terms of a values, it's not so easy, because per a day for a hospital, if you take, many patients will be coming and they may be having plenty of an problems, health issues, and if you want to remember all the health issues and all the values before and after the analysis, or before the treatment and after the treatment, for a period of some 1 year or 6 months, it's not so easy. For that, we'll be going for a graphical type of a display, not the descriptive type. So in that descriptive type, we are only measuring in terms of a values, but when you go for a graphical type, we'll be measuring in terms of a quantitative measures, in terms of a graphs. So that may be of again of different type. It may be in an approximately type of an bar graph, or it may be type of a spreadsheet. It may be a shape of a normal graph representation, or it may be a shape of an certain patterns of a graph. So these are the different analysis can be done. And in this, identifying an outliner is very important. So what does outliner means? Generally, what does the outliner means for anything? So it gives a data set. Suppose we take one data set is having a minimum value, and another same data set is having a maximum value. Suppose I'll say it is 1 and this is a 10. This is my minimum value where my data set is starting. That means if you take an example of a sugar, or if you have taking any diabetics patient, and if you want to measure the sugar, pre-sugar or post-sugar, you may be assuming some minimum value and you may be assuming a maximum value. See, suppose if you take an BP, testing of an BP also, you may be having in some minimum value and also you will be having a some maximum value. So this complete minimum and maximum comes under a comes under a data set. Now, what actually outliner means? So the outliner is a point which is outside your data set, but it is used to know your data set whether it is in your particular range or not. If anyone asks you what is your range, how do you write a range? Generally, you write a range in terms of your minimum and you write in terms of a maximum. But when you go for an example of some applications like any type of an distribution, so you can also take a consideration of an outline, because you will know the range more perfectly whether it is in terms of an your data set or not. So simplest way of representing the graphing of the data, you can see here three types of graphical methods are there. One is histograms, other is a box plots, and other is a probability plots. Probability we have already seen, and n number of plots are there. I think you remember in your probability and statistics what are the basic mathematics which we have to understand for a particular efficiency of a product. So here we can see an example. Outliners may indicate an experimental error or incorrect recording of the data. Sometimes it may happen. So if you want to avoid that, then what you should know? You should know the minimum and maximum values of the data points. If you don't know what is your low value and higher value of your data points, then you may get a problem of an outliner issue, because the value whatever is taken, it may be about 10. Example 12. I told you that minimum value is 1 and maximum value is 10. You have a many values between this, is it not? So the 12 is not in your range. But this is an outliner. But if you don't know what is your range of the thing, minimum and maximum value, then you will not understand that 12 is not in your limit. So the first type of an analysis is you should avoid the outliner and you should know the perfect analysis of an high and low data points. I'll give you one more example for this. It comes under diagnostic also. I think if you go for any blood test, or if you go for any type of thyroid test, or if you go for any sugar patients, diabetes test or anything, you can see that if you go for Vijaya diagnostic, it's just an example. If you go for Vijaya diagnostic, or if you go for a Tesla, or if you go for any other companies or type of things, okay, analysis type diagnostics labs, you can see that the range is not same. Can you observe that? Sometimes the range may be, I'm just giving an example. If the range is given for in Vijaya diagnostics was 1 to 2, and in Tesla, they'll be giving from 2 to 11 or 2 to 12, or it's based on their type of an analysis of the lab, what they have done. Okay, so this range is not same. So that's why the outer, based on outer, you cannot analyze any data. So the range is most important for any data set which you are considering. So here you can see the red one, which is indicate this is an outlier, and the blue dots which are there, that is your data which is been interpolated. Okay. So we have to understand the data, even though it is a graphical form, we have to understand in a three forms. One is measures of position, next is measures of spread, and measures of shape. The shape is also very important. You can see here. So 3 position is also important. How it is positioned, whether it is, if you take an example of an XY plot, this is your horizon, right? So you can take this shape even the left side of plane or right side of the plane, or it may be in the third quadrant, or it may be in the fourth quadrant, 1, 2, 3, 4, any quadrants. So the position is very, very important to see a central tendency, how it is between the horizon. And second thing is you have to see the measure of a spread. That is very important. The height which is there and the x-axis which it is taking from a left limit to the right limit. And also its shape. Its shape may be little bit of out in shape, or it may be exactly like an overshoot, or it may be a different shape. Is it not? So these 3 also very important. So if you take example, this is an example from a CRO, that is an cathode ray oscilloscope which has been taken. It's an example. Here you can see one graph is being shown, and for this what is important? The position is important, spread is important, shape is important. 3 are important for analyzing a signal. It may be a voltage signal, it may be a current signal, or whatever may be the testing signal which we are doing. So for analysis of a position, because we want to know the position from the origin. So if you want to know the position from the origin, what is the central point for a particular data? Is it not? If I say it's an infinite data, can you measure what is an exact point? What is the center? You don't know. So there are 3 types of an statistics analysis for measuring the measurements of the position. One is mean, another one is median, and other is mode. You have another 2 also. One is a standard deviation and other is variance. That depends upon if we are unable to measure by mean, median and mode, then you'll be going for a standard deviation and also for the variance. So total 5 parameters which are there to describe our perfect example position of your data set. One is median and mode. So we'll see what is a mean. I think I need not explain much about mean, because we know that the mean is nothing but an average value. We can say the average value of a certain values. So if you take 10 values are there, we'll be adding all the 10 data divided by 10. That is a mean value. You can also denote it by mu. That's what is denoted by mu. So it is an average value of the data set. It will tell you what is your size of the data set. Okay, so this will know what is your center point for your data set. That is important. If it is symmetrical, even though if it is unsymmetrical, then it is very difficult. If it is symmetrical, it is okay, because no outlier exactly you will be doing. If it is an unsymmetrical, that is 11 values are there. If it is 13 values are there, that is unsymmetrical, because you cannot find out what is your center difference. Left side pane will be different and right side pane will be different. So their outliers will be there, which always disturb you the exact range of the data set. So that's why the mean is one of the parameter which you measure based on your data set. Now coming into the another meaning of what is a median, right? So this is very less used because the mean is itself sufficient. But suppose even though the data analysis you are unable to do, then you will go for median, and it will also reduce the effect of the outliers, and the data which is mainly for unsymmetrical, or you can say non-symmetrical analysis, can be done easily by the median. So you see the small example here. So the total data is taken here from 23 to 44, and this is a mid number which is there, because here upper 4 are there and bottom 4 are there. So this is your median. This is a symmetrical, because upper 4 are there, bottom are there, the leftover one in the center one is your median. But if you take the number equal, that is exactly symmetrical, upper similar, no leftover is there, lower similar. So this is with outlier and this is without outlier. So you have exactly divided into 5, 5. Can you find out now what is your mean? You can find out the mean from all together divided by the total. Otherwise, for median, what you can do is you can exactly find out the specific one, what is your value. Sometimes we may feel 39 is a value because it is between 38 and 40. Okay, but let us test with the median also. It will go to the closest of your center. So that is 38 plus 40 divided by 2. That is nothing but your 39. If it is other than value, now it is here 39 and it is 40. Now if you want to go for mean or you want to go for median, again you have to do the same way. So the median is different and mean is different. The mean will tell you total values addition dated later divided by the final total number of the count, but the median will tell you the separation, the leftover whatever at the center, the addition, and only the mean of the two numbers which are left over. Now, what is the difference? So it is used for one particular application, and this is also used for one particular application. Either if you want to go for quantitative analysis, you can go for mean. If you want to go for qualitative analysis, then also you can just go into the depth. Are my slides changing? Hello, sir.
Hello,
Hello.
ma'am. Slides are not changing.
Oh, from the starting, the slides are not.
Yes, we can view only first slide.
Okay. I'll just once again. Yeah, 1 minute. Can you see the slide changing now?
No, ma'am.
Okay.
It's not visible?
It's not visible.
Ma'am, your screen is not visible.
Okay. Actually, I was doing the sharing the same way. Is PPT has been shared for you? Can you see the PPT?
No, ma'am. Now it is visible, ma'am. Now it is
visible?
okay, ma'am. Yes, ma'am.
Yeah. So what I'll do is I'll not go for full screen. Maybe I think it has some problem for visibility. So I'll be showing in this. So it was just I was giving the data analytics basic thing and 5 types of. I think now it is visible. Now
Yes,
sharing
ma'am.
is
Yes, ma'am.
Okay, then we'll go in this way. So 5 types of analytics I have explained, and I told you what is a process of a data analysis, 5 steps which are important. And we have gone for a continuous improvement of a data analysis. And what are the different applications based on the improvement maps which are there for any application, for any company, for any type of an institution or any type of an application. And we have gone for an statistics type of an analysis for a descript. So we have again 2 types in that, analytical methods and graphical type of a method. Now everyone is going for graphical representation. And then I told what is an importance of a statistics. Why do we require statistics for a data sets? That's very important. And next is how to go for descriptive statistics analysis. It is like a same like a multimeter where you'll be having an analog type of a meter and you'll have a digital type of meter where you will be measuring only the value, the descriptive statistics. But if you go for a graphical type of an analysis, you can also get the data, you can communicate with the data by seeing the graphical. And I told the example of a share market also there, right? And then we have taken an example for a graphical communication with respect to the different shape of the graph which is been obtained based on the data sets, how to conclude it. So the conclusion of a data set can be done by an outliner. So the outliner, sometimes the human error will be there, proximity errors, and we can also say errors are which are common, which has been there from the data set. So if you don't want to get an outliner error, we should understand what is the range of a data set in any distribution. So for that, we have to go for an graphing the data is very important. For that, 3 methods are there. One is histograms, box plots, and also you can go for the normal probability plots, which we have studied in some of the plots from the probability and statistics. And I was explaining about what is an experimental error. Suppose we take an example of any balanced weight type of an analysis. We may feel that the needle will be on the left side, or it may be the needle may be on the right side of your center of particular measurement. So that is called as a human error or a measurement error. But if you go for a digital type of an analysis, directly the value will be given. Example, your weight machine. If you see the older type of a weight machines, you will be having a needle which may be indicating your weight, but you don't know whether it is some decimals points. Sometimes we feel more excited, even 100 grams if you reduce also, you feel very much more excited, right? So the analysis type of an measurement, it may not give a predictive or correct value for that. So we don't take any chance for the such type of huge data. Like example I told, in a hospital where n number of patients are coming per day and they have a different health issues, and if you want to see the criticality of a patient, you cannot just take a chance based on the outliner. So the measuring of an data set of particular sample is very, very important. And to measure the data set, I have taken example, like if you take an example of a BP, so or any type of a thyroid or something, they'll be having a minimum and maximum value. The minimum and maximum value is not constant, and it is varying based on the type of a situation of a medical issue, right? So and it also varies, depends upon the type of a laboratory I was mentioning. I took an example of a Vijaya diagnostic, and I took an example of a Tesla, and I was telling the minimum maximum values of the particular data set will be changing. So what is a data set consists of? How to measure more quantitative way or qualitative way of a data set for a measurement of a particular problem, right? So for that we'll be going into and measures of position. That is a one of the important thing of measuring. Second is measures of spread and measures of shape. I was talking about the position, whether it is a center or whether it is a left pane or it is a right pane. I took an example of a 4-quadrant operation, and I was telling how the position changes. If it is a rightwards, how the x and y values will be changing. Similarly, if you take example of a spread, the spread may be the distance of the starting to the ending of your particular graph, and the shape varies in terms of an altitude. So now this is an example where this graph we can take from an CRO for testing of any type of an temperature, voltage or current for any application. Now example I told you, now if we see the season, we don't know what is the temperature, present temperature now, how much rainfall is that. So the prediction is being done by some people saying that the 3 days rain may be there. So it may be 4 days rain may be there. So it's just an analysis or prediction which is being done. So based on modeling and prediction, we cannot tell predictive statistics or predictive type of an analytics are only useful to pre-indicate you. Is it not? So we unless and until you don't go for a descriptive way of analysis, you will not understand what the data consists of. So the data consists of different types of categories. So now we are going to take a measures of position. In measures of position, again it comes under statistics. So we can measure a particular position of the graph in the 3 ways of a data set. One is a mean, other is a median, and other is a mode. We have already studied in statistics for an data set in terms of even standard deviation and also variance. So if the data is unable to identify its particular centroid position for a mean and median or mode way of analysis, then we can also go for a standard deviation and also for the variance. So now what is mean? I was explaining the mean, we already know it's an average values. So if you take example of any 10 values, we'll be taking all the data of the 10 values, adding of summation of all the data of the 10 values and divided by the total number which is been considered. So the mean also it is been denoted as a mu. I think you remember that we have already studied from the statistics. But the main concern here of the mean is whether it is a symmetrical type of distribution or a non-symmetrical or unsymmetrical type of a distribution. If you take a symmetrical type of a distribution of the data, then you will not have any outlier. That means the data will be confined within your range. But when you go for a non-symmetrical type of a distribution, example, if you see in the particular figure which is shown here, it may, the red one we can see it is an outliner which is away from your data sets, that is blue are the data sets, and the one which is a red one, it is a very far from your data sets. But the mean which is obtained is within the data set, not at the outliner. So that's how the data interpretation plays a major role here. Why we should go for data description? This is a reason. Sometimes what happens, if you write a simple C program, even though for adding of a two numbers, you may not get a perfect output. Sometimes you will get confused. I have given only two data, two variables, but I'm not getting an output. Then you'll go and add a void there. You'll add an void main. You'll also go for a null return value. Everything you'll do, but you don't understand what is happening inside. That's how we have to interpret the data. And it is not only single data or two variables, it's a very big data. So such type of an applications, you cannot just take a data for your granted, right? So we have to interpolate. Same thing happens if you take an example of your smart card. Okay, or if you take any college card, if you're swiping something, what happens sometimes, I think you know this all things in linked list also you have studied. There is a starting and I think you're also null hash which is there for a linked list also. So the data which is there in between, it is to be protected and it is to be retrieved whenever it is necessary. Then only you can access anything. So for that we are doing all this study. Okay, so we'll understand what is mean and what is median, and we have gone for now. Now the next is what is a mode. What is a mode of your particular data set? So you can see here the values which are there. The central tendency measure you have already done by mean and median. But sometimes what happens, the same distribution means what? The frequency, you can say frequency distribution or cumulative distribution, which you have studied from your probability. The data will be repeated. Sometimes the data will be increased and after it will be decreased. So there is a pattern. Is it not? So it may be a distributive type of the data. It may be cumulative type of the data. That's why if you remember in probability, we'll be measuring a distributive probability and also a cumulative probability also. So you cannot say this is one the peak. Next time, if you go for one more distribution or if you go for one more recurrence, it may come the peak value, maximum value, it may occur. So the distribution may be a unimodal type of thing. It may be a multimodal distribution. So based on that also you need to measure what is your descriptive statistics. So next category comes is minutes of the spread. So the spread refers to how the data deviates from the position measure. That is very important because you have a center point identified now, mean and median. That means you have identified your range now. You have removed your outline. Now it is clear. My data is clear. Now I'll check whether my BP is within the limits or not. If it is not within the limit, first iteration, that means first time when I'm checking, so it may be over limit. I'll note down it. Second time, third time, fourth time. So I'll see how my spread of my BP is changing for a period, is it not? So that deviates from your position of your measure. That means the position of measure is something else, center is something else, and your average, that means, is something else, and also your range is also calculated. But if you're getting spread is very large in variation, that indicates the data quality is not good. So unless and until you improve the data quality, it is very difficult to understand. That's what it happens. If you take an example of any detectives, what they do, if the capturing of any pictures from an cameras or something, so they'll see the pixels, is it not? The pixels clarity, what is been obtained. So these all applications are interrelated to your applications like big data, cloud, understanding, computing, and all are interrelated. So when you go for any specific type of an reliability, it's very, very important to understand in depth of how much spread is there. So for that, you will be going for a range and standard deviation will come into the picture. How much deviation is there from your center of the application? So for that range, we have already seen it is an inner minimum and a maximum value, and how much data is been screwed. Screwed means what? That how much data is been obtained with respect to your range. It is very maximum or it is decreasing or it is very far, or you can control it. Sometimes what happens, if the data clarity is not good but the data is necessary to measure for your application, you try to change the data in such a way the quality can improve, and you can also consider the data into the picture. Is it not? Plus or minus of the tolerance limits always be there. So this is a standard deviation where you're taking an average of all the data points with respect to the mean, here standard deviation, and also you will be measuring in terms of a standard deviation for a population. So the standard deviation is given by an S, and it is in terms of a mean also. So the population means here the data set, it will be understood in the terms of a standard deviation. So after considering this, I think this formula you already know. Standard deviation is square root of sigma x minus x bar. X bar is a mean value. X is a value for initially taking for a data set from 1 to 10. I'm taking for 10 is here maximum. And n minus 1 is n is nothing but your total count. So 10 minus.
Ma'am, excuse me.
Yeah. Is my voice audible? Hello. Sorry, is it okay?
Okay, ma'am. Okay, ma'am.
Yeah, please tell me if my PPT is not shared or my audio is not audible. Okay.
Yeah, okay, ma'am. Okay, ma'am.
This is an example for measurement of a shape. So we can see here there are different shapes I'll be showing here. One is if you go for a symmetrical type of a distribution, there is a uniform type of a distribution. The first figure will tell you the uniform distribution where the length, the width of that particular will be fixed. And another is a normal distribution where it will be increasing and other way it will be decreasing after the center line. Next is a camelback type of the thing. It will increase and decrease and again increase and decrease. Next is a bow type shaped of the type. That means it will start from a higher value. It will decrease, increase, and it will come to the minimum center. Again, it will start increasing and decreasing. So these are the different types of an analysis which can be done from the measures of the shape of the data. Because here the data getting analysis is very data analysis is very important. As I told you, if you take an electric vehicle also, there the battery charging is very important and status of the battery is important. If you see recently, I think some 1 month before or 2 months before, we have seen one article where there was a battery which has got exploded, right? So it happens because if the overheating, overcharging is being done, that happens. So you should know the state of the battery at an every time when you charge, and there should be a limit. After that it should not be charged. Is it not? Even it same happens to your mobile also. So most of the times they'll be telling you that you should not use your mobile when it is charging. That is very important, right? So based on your data, how you're collecting the data with the quality of the data, that is very important. Next is the screwness or the kurtosis type of an statistics can be done with an histogram, or you can also go for a statistical softwares are there. Example, a Minitab. It's one of the statistical software where it will tell you what is your data. Next is I told you one more variable, that is a variance, which is a measure of variance around the mean. So it is one more parameter. We can also find out it is nothing but a square of a standard deviation. These basic statistics we have already studied in our mathematics: mean, median, mode, and standard deviation and variance. So we are trying to analyze the data in terms of a statistics because we'll get some values, right? So if you want to go for a graphical type of analysis also can be done. So this is an example of a Minitab where we'll be using, this is a software. Here a example of an hospital is being considered. As I told you, high glucose levels patients at an admission can be easily scanned. So initially, if you go to any hospital, they'll check your BP levels and they'll check your sugar. If you came for any sugar test, they'll check your sugar. Otherwise, initially, random checking of a sugar will be done. Otherwise, they'll check the BP and also your weight. I think you know that. So that data, your age, your weight, and also your BP is very important for the doctor to know whether you're according to your age and gender or your health issues, right? So this data is being stored in a Minitab worksheet where all the data is being loaded here as per the date and as per the time. Is it not? So this particular data will tell you how many times you are in your limit and how many times you have crossed your limit and how many times your health is in upset stage, right? So that is to be done. So what is the descriptive research we have already done and how it can be useful now? To be frank, any type of an application related to health is a big challenge. Now it's very important. Now you see the stage of an corona type of an stage what we are there. You should scan what is their heartbeat, or you should also scan what is their state of the BP, or if you take the example of their fever condition, that is temperature. It's a very important thing that you need to identify them. Even though you have a pulse meter, even though if you have a measurement of a SpO2 types things, but still always there is a descriptive research availability or necessity for an health and also for various applications. So simple example we see here. One is a food intake and other is a frequency of an exercise. Both are very important for an obesity, which is a dependent variable. So you cannot say that if someone will say that you are obese based on your body size. So what are the important things which are necessary for it? One is the food, how you take inside, and one is the how you do the exercise. Is it not? So this is an example of an obesity where we'll be taking a two important variables of an food intake and frequency of exercise. You may think that you're taking a food intake, that is you're taking a quality food, all the nutritions, but we don't know. So further you have to go for a descriptive research of your body. Now you can see many of the softwares are there, many of the apps are there, or Healthify Me, different types of apps are there where they are measuring. But what for they are doing, they're trying to make for a human, for easy for analysis of an obesity. That is one of the concern problem which nowadays everyone have. So what they're taking is that based on your input, what you're giving. Suppose you may give that morning I had two vada with your chutney or something so and so, or 50 mg or something, whatever you're giving. So based on your input, so it will tell you what is your current situation. Are you obese today, or you have a different pedometer type of an apps which are there for frequency of an exercise. So being a computer science engineers or being an any type of an engineer, we should be available always to analyze the data, take the data properly, qualitative way, and also give a proper solution to a company or an individual. Sometimes even I feel that we don't know when rain will fall. So some predictor which will tell that now rain is falling, and it will automatically close your particular clothes, or it will protect your clothes. So we have done a small project related to that in a DST proposal. So so like that, some application where based on your data sets you can collect some data sets, and also you can also identify what actually the problems are there in the real life, identify it, collect some data. If it is real time, it will be more better, or if you are getting from a second or third party services also okay. And you can just know what is happening in the future and what are the problems which are not addressed also. So data types you can take in a quantitative way, numerical way. Example, in a class you want to know how many students are failed in your subject, or you want to know how many students want to go for an America, or anyone, how many of the students are have been placed for an in placements, or they want to go for higher studies. So that is a quantitative type of an analysis. And if you want to go for a qualitative analysis, you cannot say based on the marks the student is a quality and he has a very good knowledge. Sometimes he maybe is very good at reading and writing, right? So the quality will come into the picture when you go in depth of some participation of the student in some activities, right? So that is a qualitative type of an analysis. In quantitative, again, it is a descriptive type and a continuous type of analysis. As I told you, in a school, generally they always they'll have a health checkup, where now I think nowadays even for the colleges also, we are getting an laboratories to the college. Recently in our college, a visual diagnostic lab people have come to the college, and they were doing asking, if you want any test, we can do at your say place, and we can also give you the reports to your mail. Okay, it is possible. So everywhere at a doorstep you have an facilities now. So you can either go for a discrete type of analysis or in continuous. So take one application, what actually you want to do. Okay, think whether you want it in a quantitative way or it a qualitative way. Some require qualitative analysis, right? Example here, one example is given. You can just see here in qualitative, ordinal and nominal. If you want to take a race, if you want to take a gender, it is no ranking order, right? Gender means it's common for female, or it is common for a male, so you cannot tell. Okay, when you're taking a race, you cannot say this is different or this is different. Everyone who is participating in the race is same. Is it not? Okay, of course seniority may be there, but that comes under after once winning or losing. So if you take an example of a pain severity, you cannot also tell what is your severity. You may say it is high or less, or it is coming and going, or whatever may be based on your requirements. So these are the different descriptive type of studies which are necessary. Either you can go for sales type of studies. Now, if you see a season of such, now most of them will buy raincoats, most of them will buy umbrellas, right? Protection from the rain. So many of the buy. So this is a season where you need to concentrate on the sales or on the market, like example, like your umbrellas or things are winter wears, right? Or similarly, you can take example of now season comes where ladies will buy the gold or sarees and etc. So that's how the share market will change. Now everyone is having a YouTube. Now everyone is doing some analysis through the selling of a third party services, right? Like if you take an example of a Misho app, or you go for an Inventra or anything type of apps. So the consumer and behavior is very, very important. What the consumer and what the data which you're collecting is as per the consumer or not. That is very important. Is it not? And market characteristic studies also very important. Sometimes what happens, it is needed the data, but it is distributed to everyone. It is commonly. Is it not? Now climate information weather report, it is common for everyone. But if you see some market analysis, it is not common for everyone, is it not? If you take an example of a gold rate in Hyderabad, maybe little bit of difference from Chennai. So it's a competitive. Now, if the gold rate is less there, they may go there and buy. Depends upon the requirement, depends upon the competitive analysis. So what actually the meaning of this particular data analysis is, take one example. As an example, I'll just give you one final example for this. Now I'm interested in electric vehicles or hybrid electric vehicles. So I take an example of an electric vehicle where the present status of the battery is very important for an electric vehicle. So for the battery monitoring and its values, I'll take the data from the sensors. Okay. After getting the data from my battery, what is my next step? I need to understand the battery characteristics. Is it not? The 5 steps which are important, which I was showing here. Identify it, collect the information, whatever you get from the data. And if the data is not clean, clean the data, because you don't want any garbage values from your output of your C programming, as I told you. So clean it, analyze it and interpret it, and you see whether the interpretation is done as per your requirement or not. That's what is to be done. This is a brief thing which I was telling about a descriptive analysis. Hope you take one example and try to write a code. Even it is C programming, you need not go for any application specific type of interfaces. You can use simply a MATLAB thing for, or you can simply use a C programming, but take some data and try to write it. Then you'll understand how it has been there. Now, if you go for a MATLAB, you have a guide programming there, and you have a many type of an application specific type of an graphical user interfaces where you can do it, right? So that application you can do for a small application and see how you're going to get a result. It will be very interesting to watch out, right? Sir? So I'm done with the topic. So if anyone want to discuss anything, you can please ask questions, or if anyone want to discuss, you can discuss. Am I audible, sir? Anyone want to ask any questions? So we can take some application and we can do some type of research on the data. Then we can see how it is working for a practical application. It will be better if you take an example of a solar panel or something, and you can take the data of an irradiance of the data, and also we can take the irradiance and temperature of a solar panel, and it will be changing with respect to time. And very good example, as I told you, hospital, and another example is a battery status of an electric vehicle. So many practical problems are there where the data requirement is there. So we can take a small example and we can also do it on research of type of some activity on it, and you can write some programming on it, and we can see how the data interpretation can be done based on its position or width, and we can see whether it is fitting our data set or not. Any more doubts? For an application, we can use also an multilinear regression. It is an old topic, but many of the applications are not being done by using a multilinear regression. So we can also go for a multilinear regression for that application.
Madam, I have one doubt regarding why we have such different types of technologies like data science, big data, and business analytics. So all these among all these technologies, we have one programming language. Python is being common, and some other technologies are using R programming also in addition to Python. But Python being the prominent. So why we have these many kinds of technologies in the current era? Because we have Python is a common programming language used among all these technologies. So we have again if you take data analytics, we have predictive data analytics, descriptive data analytics, and all these. So what actually are the differences between why we have these many technologies? What is the role of each technology in the current era?
Yes, it's a very good question, sir. Because if you take a simple example, I'll just explain in this way. We have different techniques, we have different applications, and we have different application may be same, but the requirement of an measures earlier and now are changing. If you take example, I may want something a product which is not required earlier. If you see in the olden days, that product of washing machine or the oven is may not that much be useful for me at that time, but now I'm using it because I want some commodity to help me more easier. Is it not some mixer or something which I want more easier? So these are different regression or deep learning or whatever the techniques we are seeing now. They want to give a classification of a data sets based on their applications and the size of the data, and they vary also depends upon the requirement of your accuracy in terms of your measurability. So that's very important. Sometimes what happen, you are, if you take an example of one method, simple example like C programming you are using for getting the data through your serial communication or a parallel communication. You are getting the data, smart card access, you can do it even by serial communication also, or by parallel communication through your C programming. But what happens is some data corruptions will be there or some errors will be there. Some cannot be rectified by C programming. So you will be going into depth of a clarity for using an higher version of that particular programming. So we are improving the products in such a way, you are adding one feature and you are making into a product again. So if you take example, it is enough even you go for a machine learning. But now you're saying that big data analysis is there, cloud data, everything meaning is your data to be protected. Simple example. Now I'm
Yes,
talking to you. Simple data is that your data is to be protected, and everywhere they're using a statistics again. So the maths is common, the mathematics is common for all type of analysis. Only thing is what is a feature you want. That's an important. Now I'm comfortable with go with an auto from one place to another place, but I may comfortable to go with a train, but I have a flight. Then you'll ask me question why I want a flight, because it is a comfort. It's a comfort and it takes very less time when to reach my place. So rather than train, I prefer sometimes flight. But if I'm seeing about my economic basis, I may again go back to my train. So it's only the methods main difference, in-depth application difference, it will be something different. If you take an example of electric vehicle, which I was telling for a battery, if you go for same thing you're doing by deep learning, you make it something analysis, data wise analysis different. But if you go for and doing by a machine learning, you may get the same data, but the analysis way of interpolation may be different. But only thing is you're upgrading yourself. These all techniques are just upgrading. That's all, sir. If you take
Okay,
example of an artificial, you're upgrading in such a way that adding one feature and giving it to a name. That's all. But the whole story is again same. The input will be there, output will be there, and the data will be there. Where you want the data to be secured throughout, it is reaching from input to the output. Same thing is what happening.
Thanks, madam. Thanks for your answer.
Yeah, thank you, sir. Any more queries?
Hello, participants. Is there any queries from your side? Okay, ma'am. Thank you for your very wonderful session, ma'am.
Thank you.
We
sir.
have learned so many concepts from the bottom scratch to the recent trends in the applications, ma'am. Okay, and we have learned so many statistical methods how to apply in research area. We have learned so many things, ma'am, from you. As a faculty, also we have learned so many things, ma'am. Thank you very much, ma'am. Okay, thank you, ma'am.
Thank you, sir. Can I answer?
Dear participants, just attendance link will be posted in our group. Please fill in half an hour